Hi, good morning everyone. Today I would like to share with you some example on the convolution, how to solve it by using the graphical method. Okay, now let's look at the example. Okay, perform the convolution of these signals, which is xt and the hash t, by the graphical method and sketch the resultant signal. So you need to sketch the signal at the end. Alright, so how to solve this kind of question? But first of all, you need to know the definition of the convolution. Okay, do you still remember what is the definition? All right, this is the formula that you need to know. That is the output yt is equal to the integration from minus infinity to infinity x tau hash t minus tau d tau. So this is the formula that you need to know, and you will need to use it later. Okay, first of all, for the first step, the first step to solve the convolution using the graphical method is you need to write the function as tau. Okay, so you need to write as function of tau. Okay, what's mean here? Okay, if you look at this input xt and the hash t, so you need to change it into the x tau and d hash tau. Okay, so you have the x tau here, you change xt to x tau, and then you change the hash tau, hash t to hash tau. So this is simple. Okay, what is next? The second, step number 2, is you need to flip. You need to flip or fold it. Fold the hash tau to get hash minus tau. Okay, so you fold the hash tau. Then you will get this one. So this -2, -1, this is 1 and -1. So this is, we call it hash negative tau. Alright. And step number 3 is shift the hash negative tau by t units. Okay, to get the hash, to get hash t minus tau. Then multiply with x tau. Okay, what's mean here? Now let's see. You have the x tau and hash t minus tau, right? This is the hash negative tau, so you change it to hash negative tau. Okay, so this is you fix the x tau. So x tau, you fix it. Okay, I changed it to a different color for the signal. Okay. So this is tau. For the hash tau, so this is hash t minus tau. So you slightly backwards. So you have hash t minus tau. Okay, so this is -1 and this is -2. This is 1 and still remain -1. Okay, so this is this part is the x tau. So the first one is the x tau, the second one is the hash t minus tau. Okay, from previously is you get is hash negative tau, right? So you slightly shift to the left is the hash it turns to the hash t negative tau. So what is the overlapping region? Any overlapping region with this one means that the x tau multiply with the hash t minus tau. No, right? There's no overlapping region. So no overlapping region means that for t less than 0, the yt is equal to 0. Okay, you need to find the overlapping region. Now, next. Okay, so you draw again the x tau. And then you shift. So just now is for t less than 0. For t less than 0 means that this is 0 here. For t, so the first one will be the t. Okay, the first one will be the t. T less than 0. Okay, this is 0. This is 0. And the t is here. So for t less than 0, there's no overlapping. Okay, now you shift the t. You shift the t from in between 0 to 1. Okay, let's draw the signal first. So this is the signal 1 and 2. Okay, then you shift the signal. Okay, this is 1 and 2, right? This is also 1, this is also 2. So you shift the hash t minus tau in between 0 to 1. So 0 to 1 is here. So you just shift like this. Okay. So if you look at here, any overlapping region, this is okay, let me see this hash t minus tau. Okay, is there any overlapping region if you x tau multiply with hash t minus tau? Yes, there is an overlapping region, but where is the overlapping region? Can you tell me where is the overlapping region? If you look at here, okay, you make a line. All right, so this is the overlapping region. This one, this region overlap with this region. Okay, so don't forget the first one is the t, right? So for the overlapping region, so this one is the overlapping region. For t less than 1 and more than 0. Okay. So your overlapping region, based on just now, the formula I gave it to you, this one, this formula, x tau multiplied with hash t minus tau. Okay, so yt equal to integrate. Okay, so integrate, you need to know the limits. Okay, if you look at this figure, 0, the overlapping region is 0 to t here, 0 to t. So that's why the limits is from 0 to t. And then the x tau, for the x tau is 1, hash tau also 1. So you have 1 multiplied with 1 d tau. So you get integrate 1, you get tau. Then t0. So you get t minus 0 is equal to t. Okay, now we look at another one. Shift again, the t shift again from 1 to 2. From 1 to 2. Okay, let's draw again. Okay, let's draw again. The signal with red color. 1, 2. Okay, and then you shift the t from 1 to 2. 1, 2, 3. Okay, you shift. Just now it's 0 to 1, right? Now it's 1 to 2. 1 to 2, so your signal will be here. Okay, so is there any overlapping region? If you look at this one, is there any overlapping region? Yes, right. So the overlapping region, you will just tap up. So this is the overlapping region. Okay, here as well as here. Okay, so how do we write the signal? So this one also a overlapping region. For t less than 2, more than 1. Okay, and then the yt. Okay, now how to write the signal? The first one is t. The second one, we call it t minus 1. Okay, t minus 1. And then the second one, we call it t minus 2. Okay, so your signal is from here to here. Okay, so let's say now you have 0 to t minus 1. Okay, 0 to t minus 1 means that is this part, 0 to t minus 1. What is the value? Here is 1. Okay, x tau you have 1. Ht minus tau you have negative 1. Okay, time with negative 1, d tau. And then plus with, okay, this part. So integrate, this part is t minus 1, right? T minus 1 up to t only. So t minus 1 up to t. So the value is 1 and 1. So 1 times 1 d tau. Alright. So here you have minus 1. So in your integrate, you obtain negative tau. T minus 1, 0, plus with 1, integrate 1, you get tau. Okay, you substitute the value of tau with the value t minus 1. So you have negative t minus 1 plus t minus t minus 1. So you get negative t plus 2. Okay, so again, you have to continue shift. You shift until there's no overlapping. Okay. Okay, just now is from 1 to 2. Now is 2 to 3. Okay, 2 to 3 means that the signal is like this. Okay, so is there any overlapping region? Okay, 2, 1, 2. Yes, right. There's an overlapping region. This part and this part only. Okay, how to write the signal? So this one also overlapping region. For t less than 3, more than 2. And then your yt is equal to, let me use the black color. Okay, yt is equal to, okay, from here this is t minus 2. Again, this is t minus 1. So this is t. So is here to here. So t minus 2 to t minus 1, you have the value of, this is 1 and this is negative 1. So 1 multiplied with negative 1 d tau plus with, get this part. This part is t minus 1 up to 2 because after 2 there's no overlapping. Okay, so the value is still 1 times 1 d tau. Okay, so you get this one, negative tau, and then plus with tau So you just substitute the value, then you will get the answer. So at the end, you'll get negative t plus 2. Okay, so you still have overlapping, which so you need to continue to next one. This xt always fixed. X star always fixed. You just move the hash t minus tau. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So your overlapping region is just 3 to 4. Okay, 3 to 4. Okay, so is there any overlapping region, class? If you look at here, okay, 2, and this, only this part. So your overlapping region is only this part. Now you can say that for t less than 4 and more than 3, your yt value is, okay, so this part is t minus 2, right? So it's t minus 2 up to 2 only. Then 1 time with the negative 1, d tau. So you integrate, you get negative tau, and you get the limits. Then you get negative 2 plus t minus 2. Then you get t minus 4. Okay, so you still have the overlapping region. You need to do until no overlapping. So try again. Okay, try again. This 1, 2. Okay, 1, 2, 3, 4. 1, 2, 3, 4. And then just now it's 3 to 4, so it should be 4 to 5. 4 to 5. Okay, so 4 to 5. Okay, so if you look at here, there is 2. The 2 is here. There's so x tau and is not overlap with ht minus tau. So this one we consider it as a no overlapping region. So yt for t more than 4, there's no overlapping already. Okay, 4, 5, 6 also the same. So we just simply said t more than 4, there's no overlapping region. Therefore yt is equal to 0. Okay, so you stop the moving, then you assembly the output signal. So step 4, you just combine all the signal. You get yt equal to 0 when t less than 0 and equal to t for t from 0 to 1. And then you get negative t plus 2 for t 1 to 3. Why I said 1 to 3? If you see that from 2 to 3, you get negative t plus 2. Okay? Negative t plus 2. For 1 to 2, you get negative t plus 2 again. So I just simplified that from 1 to 3, you get negative t plus 2. And then for t more than 4, you will get, I think 3 to 4 I haven't. Alright, next. For 3 to 4, you get t minus 4, and then for t more than 4, you get 0. So you just assembly or you combine all the output signal. After assembly the output, you may plot the graph. Okay, you may plot the graph of the yt. Okay, how to plot the graph yt? So let's say you know that the t is from t equal to 0 to t more than to at least t more than 4. Okay, t equals 0. There's a graph. T less than 0, you will get 0. T more than 0, you will get 0. So only this graph you need to plot. Okay, so you know that is in 0 to 4, you have the value. So you can add t equal to 0. So y0 equal to 0. Okay, so when t equal to 1, the y1 equal to 1. You substitute the value of t. Yeah? And for t equal to 2, you substitute the value of t, and then you get negative 2 plus 2, so you get 0 again. And then for t equal to 3, so you have y3 equal to t minus 4. So it's 3 minus 4, you get negative 1. And then for t equal to 4, you get y4 equal to 0. Okay, so now you can plot. Okay, so you have 1, 2, 3, and 4. So for t equal to 0, you have 0. For t equal to 1, you have 1. For t equal to 2, you have 0. For t equal to 3, you have negative 1. For t equal to 4, you have 0. Okay, so this is basically the YT graph. The YT graph. Alright, do you understand now? Okay, thank you for watching, class. Okay, see you again.